Good morning everyone. My name is Sanjana. I am studying BTech first year in IIT Patna. Let's study an important chapter from organic chemistry, haloalkanes and haloarenes. We already know about the hydrocarbon which contains hydrogen and carbon only. Let's see halogen derivatives. When one or more hydrogen atoms are replaced by halogen atoms, fluorine, chlorine, bromine and iodine, the compounds formed are called halogen derivatives. Here they will be in the form of HX. X is fluorine, chlorine, bromine and iodine. If halogen is attached to an alkyl group, this is called haloalkane. These alkyl groups are methyl, ethyl and etc. If a halogen is attached directly to an aromatic ring like benzene ring, then the haloarenes are formed. If halogen attached to alkyl group, it forms like CH3X. Here the X belongs to halogen atoms. Now classification of halogen compounds. Based on number of the halogen atoms, they are divided into three types like monohalo compounds, dihalo compounds and polyhalo compounds. If there is one halogen in a particular compound, then it is called monohalo compound. In methyl chloride, there is only one halogen, that is chlorine. So, this is called monohalo compounds. There are two halogens, dihalo, and if there are more than two halogens, this is called polyhalo compounds. Now, based on the type of carbon-halogen bond, they are divided into another two more types like haloalkanes and haloarenes. If the bond between the carbon and the halogen that we take is sp3, then this is called haloalkanes. Like if we take CH3Cl, the bond between the carbon and the Cl is sp3. So this is called haloalkane. Here, when we take a primary carbon, it comes under the primary category like CH3CH2Cl. Here it is primary. If we take here, the carbon is secondary as there are two methyls and one hydrogen. So this is secondary. And if the carbon is tertiary like three alkyl groups and one chlorine, this comes under tertiary. And there are special types in this like allylic halides, in which the halogen is near the C double bond C bond. Like if this is C double bond C and CH2Br. Here halogen is near to this double bond of between two carbons. These are called allylic halides. Benzylic halides are the halogen which is present next to benzene ring. Like if we take benzene ring, here if the halogen is here, it is haloarene, and if the halogen is here, this is benzylic halide. Here we should take care between these two. This is a haloarene. And coming to the stability, this is very much stable than this. So benzylic halides are more stable. We can see about this due to what is the reason for the stability of the benzylic halides later on. Now let's see haloarenes. Here also we have seen the haloarene example. That means the halogen is directly attached to benzene ring, and the bond between carbon and the X is sp2 hybridized. Here is sp3 hybridized. This is the difference between the haloalkanes and haloarenes. Now let's go to nature of CX bond. Here, coming to the nature, this nature of the bond depends upon the electronegativity character. The carbon is less electronegative than any other halogens. So due to the more electronegativity character of the halogen, it gets partially negative character, and carbon gets partially positive character. From the periodic table, we know that the bond length increases as we go down the group. See here, fluorine, chlorine, bromine, iodine. The bond length is decreasing. This is due to the small size of the fluorine and the big size of the iodine. And bond length, as we know, bond length is inversely proportional to bond strength. As the bond length increases, bond strength decreases. Now let's see the preparation of the haloalkane. These haloalkanes can be prepared from the alcohols. This is the most important preparation which we must know. That alcohol plus halide gives rise to haloalkane. Let's see this. Ethanol plus HCl gives rise to chloroethane. CH3CH2OH plus HCl gives rise to, here the OH is replaced by Cl and we get the chloroethane. This is one of the best preparation of the haloalkanes. Here when we use a special reagent called SOCl2, this reaction performs very well, like the pure alkyl halide can be formed, as the byproducts of this reaction are gases SO2 and HCl. Due to this byproducts we get very pure alkyl halide, as these gases can escape very easily when the reaction has done. Here for preparation of the haloalkane, the reactivity order of the alcohols are 3 degree, 2 degree and 1. Tertiary is more reactive than, secondary is more reactive than primary. Now let's come to the preparation of the haloalkanes from alkenes. Here from alkenes we follow a Markovnikov's rule. Let's see that if we take any alkene and HCl, it forms, from the Markovnikov's rule, we know that the negative part of the compound adds to the carbon with less number of hydrogens. This is the rule of the Markovnikov. Like H plus and Cl minus will be formed. This negative part will add to the carbon with less number of hydrogens on the double bond. Here there are 2 hydrogens. Here there is only 1 hydrogen. So this add here and here. In this way we formed haloalkane. Now let's see the physical properties. We generally know that they are colorless and the boiling point will be higher than hydrocarbons. And the order of boiling point will increase as we go down the group. Insoluble in water but soluble in organic solvents. Density increases with number and the size of the halogens. As these halogens are very heavy and the carbon is also heavy, here the density increases. Let's see the chemical reactions of the haloalkanes. They are nucleophilic substitution reaction. A nucleophile, here in nucleophilic substitution reactions, nucleophile replaces the halogen. In SN2 there will be 2 SN2 mechanism, SN1 mechanism. In SN2 mechanism occurs in primary haloalkanes only. The reaction will be best in primary haloalkanes only. This leads to the inversion of the configuration. We already know about the configuration. Due to this reaction occurs from the back side, this leads to the inversion of the configuration. The reactivity order is 1 degree, 2 degree, 3 degree, which means a primary haloalkanes can be done easily. Where SN1 is quite opposite to SN2, means the tertiary haloalkanes are more reactive here, and also an intermediate can be formed here. That is, carbocation will be formed in the reaction, leads to racemization here. Now let's see the elimination reaction, where now let's take one haloalkane. Here we took haloalkane and the alcoholic KOH. Here as we took a very strong base, we get the product like this. Here we use strong base, so major product and very stable product will be formed by following the Zaitsev's rule. And as we have already discussed about the polyhalogen compounds, they also causes effects to the environment. These are the different effects they cause. And today we have learned about what halogen, it reacts with the hydrocarbons. They form haloalkanes and haloarenes and their classification, preparation, properties and many more. Thank you. Thank you so much.